Hey guys, coming in to you live from Fiji. Woo, you're right. So I wish. Okay, so I hope these follow alongs are helping you out. We're still on genetics. So the face lab, if you guys have questions, I do step by step on these labs. So please watch them. Um, it's to help you guys out and to walk you step by step. So usually if you ask me for a Zoom meeting, I'm just going to tell you what I'm just saying on here. But again, you guys, if you need help, please, ask me, and don't just say, I don't understand any of it. Specifically, what don't you understand so I could help you? So I have uploaded Punnet squares. I know you guys are familiar with them. I'm going to do two problems with you, and then you guys have two problems, and they're very similar. So I'm going to share the screen with you. And this is a notability worksheet. So, write your name. I shared these with everybody. I'm just going to put key there. Whatever period you are, whatever date. So Punnet squares, I know you've worked on these before in 7th grade, I believe. You did a lot of SpongeBob stuff. So the Punnet square is a chart. It's used by geneticists to help determine the chances of an offspring receiving a particular characteristic. The Punnet square will not tell you how many offspring will develop or the order that they'll be born. They just give you the probability or the chances. So say for example, you had two parents, here's mom, here's dad. They're both heterozygote for brown hair. So big B means that they have brown hair. Little b would be blonde hair. So big B is the dominant trait. Little b is the recessive. So this parent, they can either give their big B or their little b. They have a brown haired allele or a blonde haired allele, and same with the other parent, brown or blonde. So parents' gametes, they go up top. And then when you guys are figuring out, which ones, these hate me. Okay, so this one is going to be, you're going to take this one and this one, where they overlap, that's going to be big B, which means it's homozygous dominant. This one is big B, little b, because wherever, like this one's going to go there, this one drops down, this one drops down. So it is, here, I'll just do this. This one's going to be big B, little b. And then this one is big B, little b. So, oops, sorry. This one is not big B, little b. This is little b, little b. So what are the chances of the offspring being homozygote brown hair? So what that means is, what are the chances? It hates me. Get over here. What are the chances of it being big B, big B? So how many in that square are big B, big B? So 1 out of 4. This hates me. Trying, all right. 1 out of 4, or 25%, will be big B, or homozygous dominant. All right. What are the chances that the offspring will have blonde hair? So to show blonde, you have to have both recessives. So this one right here, little b, again, it hates me. It's not typing on there for me. I should just write it. Little b. I swear these hate me. I'll do it like this. Why do you hate me? All right, whatever. The chances of it being little b, That looks awful. I'm gonna try it again. I don't know why this, there we go. Little b, why do you not select? You know how I always said I'm gonna throw my computer out the window all the time? It's getting there too. All right, finally. I don't know why that doesn't show up sometimes. Little b. Again, it's 1/4 or 25% homozygous recessive. What are the chances of the offspring being brown-haired? So brown. Why does this hate me? I honestly do not understand. All right, I'm just gonna do it. Okay. All right, so the brown hair could either be big B, or big B, little b. So we have these 3 kids could have, they're gonna show brown hair. So if the big B shows, that would be 3 out of 4 or 75% show brown hair phenotype. Remember, phenotype is the physical look. Genotype is like this. These are the genetic alleles that they'd have. What is the genotypic ratio? So when you guys are writing genotypic ratio, I don't want you just to put 1 big B, or I don't want you to put 1 to 2 to 1. I want you to put, we have 1 big B to 2 big B, little b's to 1 little b. So that's how I want you to write out your genotypic ratio, because these are the alleles that would show, and you have to tell me what's 1 to 2 to 1. If you just write 1 to 2 to 1, I won't know what you're talking about. The phenotypic ratio is the physical look. So physically, how many brown hair, how many blonde hair? So we got 3 brown hair to 1 blonde hair. So again, when you're writing the phenotypic ratio, I want you to, again, make sure that you put, you know, what they will look like, what physical trait. What's the dominant gene? Big B, that's brown hair. Is there a heterozygous brown or blonde offspring? And no, because big B, brown, is dominant. Is the dominant allele. And if dominant allele shows, then is present. Dominant allele is present, then the brown shows. Okay? So that is those. Okay, now this one, when you are doing your alleles, I'm not going to do this one for you. I'll set it up. It's like the same thing. I'll do 8 through 12, and then you guys have to do 13 through 19, which is the same thing. And then I'll help you out with this 20 as well. All right, so if you had curly hair, dominant to straight hair, what letters are you going to use? So when you have dominant recessive, use the same letter, but make sure you capitalize in lowercase. So we'll use a big C for curly and a little c for straight. If heterozygote curly-haired male marries a straight-haired female, what would their genotypes look like using the letters in question 8? So heterozygous, remember hetero means different, zygos, different letters. So is curly-haired male. So right here would be big. Don't like these things. All right, I'll do it this way then. All right. So heterozygote curly hair is big C, little c. And a straight-haired female would be little c, little c. What would the gametes be for the male parent? All he could give would be, he could give, sorry, I'm getting used to this. He could give his big C or his little c. The female could only give her little c or her little c. So work on the Punnett square below. When you set these up, you are going to put either parent on top or on bottom. So if you put the mom on top, it would be little c, little c. But let's put the dad on top. We'll have big C, little c. And then the mother is on the side, little c, little c. And then you do the same thing that we did above. So if you need a review, go back, rewind the video and look. So those ones are pretty much the same. You're gonna have different genotypic ratios, phenotypic ratios. The dominant gene would be curly haired, and 19 is pretty much the same as number 7. So, and then I'll set up 20 for you. If yellow pods are dominant to green pods, what letter would you use? I gotta keep doing this. So we will use big Y for yellow, little y for green. If a heterozygote yellow male is crossed with another heterozygous female, what would their genotypes look like? So that's going to be big Y, little y, and you will have big Y, little y. Oops. Okay, so these are the genotypes. Why this is all the way down there. The gametes be for the male parent. He could either give his big Y, little y. The female parent, she can also give big Y, oops, big Y, little y. And then again, you're gonna work out the space below. So the dads are gonna go here, big Y, his gamete, little y. And the mom, big Y, little y. And then again, you're gonna work out the genotype and phenotype. And again, number 31 is exactly the same as the other ones. This one's very similar to question number, this is supposed to be little y, by the way. Question number 1. So, you know, you have heterozygote, heterozygote. So anyway, work those out, turn them in, and if you have any questions, email me. All right, so that being said, peace. Here, my other dog wants to say hi. Hi. Oh, Fiji's gone. See, Rena says bye. Miss you guys. Stop recording. It's not stopping.
It's not stopping.